Earth's climate and chemistry operate through complex feedback loops that might produce sudden transitions under certain conditions. But they could also indicate something else entirely. What if some of these gaps represent periods when previous civilizations dominated the planet? Their industrial activities might have altered environments so drastically that most existing species went extinct, creating apparent gaps in the fossil record. The rapid emergence of new life forms might represent either evolutionary responses to changed conditions or evidence of genetic manipulation by advanced beings. The rock layers themselves contain even stranger evidence. Every factory, every power plant, every piece of heavy machinery leaves chemical fingerprints that persist long after the structures themselves crumble to dust. These signatures become incorporated into Earth's geological record, creating permanent evidence of industrial activity that can survive for millions of years. Modern industry produces distinctive isotope ratios that differ dramatically from natural processes. When we burn fossil fuels, we release carbon that has been locked underground for millions of years. This ancient carbon has a specific isotopic signature that shows up clearly in atmospheric measurements and gets preserved in tree rings, ice cores, and marine sediments. Nuclear weapons testing created radioactive isotopes that appear nowhere in nature. These artificial elements will remain detectable in geological samples for thousands of years, providing future scientists with unmistakable proof that an advanced technological civilization existed on Earth during the 20th and 21st centuries. But here is where the mystery deepens. Geologists have discovered similar anomalous isotope signatures in rock layers that predate human civilization by millions of years. The Permian-Triassic boundary, marking the Great Dying 252 million years ago, contains carbon isotope ratios that mirror exactly what we see from massive fossil fuel combustion. The scale of this signature suggests an event that released carbon equivalent to burning all known coal, oil, and natural gas reserves on Earth within a relatively short geological timespan. Traditional explanations invoke massive volcanic eruptions or methane releases from warming oceans. These natural processes could theoretically produce similar carbon signatures, but the precision and timing of the isotope changes suggest something more systematic than random geological events. Deep ice cores from Antarctica contain atmospheric samples stretching back 800,000 years. Within these samples, scientists have identified periods of rapid atmospheric change that resemble what we might expect from large-scale industrial activity. Concentrations of greenhouse gases spike suddenly, remain elevated for thousands of years, then return to baseline levels. These patterns appear multiple times throughout the ice core record, always preceded by subtle changes in atmospheric chemistry that suggest coordinated manipulation of planetary systems. The changes are too rapid and too systematic to result from known natural processes. Rock formations in Colorado contain microscopic spheres of titanium and other rare metals arranged in layers that correspond to specific time periods. These spheres are identical to particles produced by high-temperature industrial processes, yet they appear in geological strata that formed long before humans developed metallurgy. Similar metallic anomalies have been discovered in sediment cores from deep ocean basins. The metals are distributed in patterns that suggest widespread atmospheric dispersal, as if they were released by numerous industrial sources operating simultaneously across different continents. Ocean sediment cores reveal additional evidence of ancient industrial activity. Layers of sediment contain concentrations of synthetic compounds that should not exist in nature, yet they appear in geological contexts that predate human chemistry by enormous margins. These chemical signatures could have natural explanations we haven't yet discovered. Earth's geological processes are incredibly complex, and we may be misinterpreting evidence of unusual but natural phenomena. However, the patterns are becoming too numerous and too systematic to ignore. The evidence extends beyond chemistry into the realm of materials that shouldn't exist at all. Plastic will be humanity's most enduring legacy. Long after our cities crumble and our bones turn to dust, microscopic plastic particles will remain embedded in sediment layers, providing future geologists with unmistakable evidence that an industrial civilization once dominated this planet. Plastic breaks down extremely slowly in natural environments. Even when exposed to sunlight, heat, and chemical weathering, plastic fragments persist for hundreds or thousands of years. In deep ocean sediments or frozen environments, plastic could remain virtually unchanged for millions of years. This durability makes plastic an ideal geological marker. Future scientists examining Earth's sediment layers will discover a sharp transition where plastic particles suddenly appear in enormous quantities, marking the beginning of what geologists might call the Anthropocene epoch, the age when humans began reshaping the planet through industrial activity. But recent discoveries suggest we might not be the first civilization to leave such markers behind. Sediment cores from remote ocean basins contain microscopic particles of what appears to be synthetic polymer compounds in layers that formed millions of years before humans invented plastic. These particles display characteristics identical to modern plastic fragments, including resistance to natural degradation processes and chemical compositions that don't occur in nature. The particles appear in discrete layers separated by millions of years, suggesting multiple episodes of widespread synthetic material production, followed by complete cessation of the activity. The distribution patterns indicate global dispersal, as if these materials were being produced and used by a planet-wide civilization. Advanced analysis reveals even more puzzling details. Some of these ancient polymer fragments contain molecular structures that represent improvements over modern plastic technology. They show evidence of engineering designed to enhance durability and resistance to environmental breakdown, suggesting their creators possess sophisticated understanding of materials science. Deep drilling projects in Antarctica have recovered ice samples containing similar synthetic particles in layers that formed hundreds of thousands of years ago. The particles are perfectly preserved in the ice, maintaining their original molecular structure and providing clear evidence of their artificial origin. These discoveries challenge everything we thought we knew about materials science and planetary history. Either natural processes can somehow create perfect polymer mimics under conditions we don't understand, or previous civilizations developed advanced chemistry long before humans appeared on Earth. The timeline implications are staggering.